Hello, everyone, and welcome to the Android stage of I/O Connect Berlin 2026. Get ready, because we have a day full of technical talks for you. We have deep dives into AI integration, we have developer tooling, we have developer productivity, everything, performance, I don't know. We have a whole range of things today. Now, my name is Jolanda Verhoef. Some of you might know me, some of you might not. I'm the speaker of the first talk together with Ben, who will be joining me soon. And what I want to do before we get into those deep dives is I have a couple of things that I need to share with you, a couple of household items, so to say. And before we start our AppFunctions deep dive, I want to give you a quick look of how the Android operating system is changing, because we're making quite fundamental changes. And at a top level, AI on Android consists of 3 core pillars. So first of all, we have the Android operating system that is evolving into an intelligent system, and you can expose your app's capabilities to that system. Second, in-app intelligence lets you bring intelligence into your app, so you can bring cloud and on-device models into features in your own apps. And finally, developer productivity lets you use intelligence to build your apps. So this is the things like Gemini in Android Studio, stuff like that. So with those 3 core pillars, they're all very important to the future of Android, and they're our commitment to embedding intelligence throughout your entire Android lifecycle. Now, all 3 of them are crucial, but the main focus of our talk today will be on the first 2 pillars. Now, throughout this talk, what we're going to do is we're going to showcase Jetpacker. This is a demo app that my team has been building over the past couple of months. We first introduced it at I/O this year. We're currently working on making the app open source so that you can check it out yourself. But today we're going to continue basically where we left off at I/O. So we want to make sure that we're showcasing new things to you today. So let's get started with a quick overview of in-app intelligence. When you're adding intelligence to your app, you can choose between a lot of different things. You can choose for on-device, hybrid, or cloud inference. Or if you want a more complex setup, you can use an agent that runs in the cloud, or you can even use an agent that runs on-device. So what I recommend you do is actually go to YouTube and watch this I/O video of me and Thomas, where we dive into all 5 of those topics in a lot of detail. Throughout the talk, what we do is we are implementing 7 different intelligent features into the Jetpacker app. So we start with a travel app that basically is just doing nothing very intelligent, just showcasing travel trips. But then we're adding one by one different features, showcasing the different APIs. Now, there's one of them that I do want to show today. And the reason for that is that is the one that actually Ben will use later in a certain amount as well. So this is the one that is tracking your budget and your expenses. Because I don't know about you, but when I'm traveling, normally I end up with a whole bunch of receipts. Like, they're always stuck in my bags, in my coat, everywhere. And it's always quite a hassle at the end to figure out, OK, do I still have budget for things, because I'm paying with different payment cards and stuff, or to figure out, like, my expense management, what does my company need to pay for me, et cetera. So for such a tedious task, wouldn't it be nice if we could let AI do the work for us? So here's a demo of what it could look like. So here I have my app, and what I'm doing is I'm turning on this feature. And now I go to my current trip, which is a California trip, and I go to the expense management. And as you can see, I already have a bunch of different expenses going on, but I can also take a picture of a coffee that I ordered that morning. So here I'm taking the picture, and now my on-device model is going to parse that image, and it's going to extract information for me. Pretty cool. It gets the number right, it gets the name right, it categorizes it. So what does that look like in code, right? So what we do is we're using on-device inference, is what I'm saying, which means that we can do this fully offline without any cloud inference costs, and the user can be confident that whatever that receipt was, that data is not going to go to the cloud. So when we're building with on-device, what we're doing is we're using Gemini Nano. Gemini Nano is Google's most efficient model that is optimized for mobile devices. We first introduced Gemini Nano a couple of years back, and by now we have over 140 million devices that are using some version of Nano on Android. So that's quite a big user audience. Nano 4 is the newest one, which will be available on Pixel 10 devices later this year. And it especially, it's multimodal, so it's especially great at parsing image information for tasks like OCR and visual data recognition. So naturally, for our receipt parsing, this would be a good thing to use. So if we look at our code, the absolute fastest way to get started is to use the MLKit GenAI prompt API. This gives you a clean, idiomatic Kotlin interface that you can work with. And so in our case, what we can do is we can send an image part and a text part. So in this case, I'm sending the image of the receipt, and then I'm sending a prompt. And in my prompt, I'm specifying that there's 3 things that I want to get from the image. I want to get a title, I want to get the amount, and I want to get the category. And then finally, I'm actually telling it what JSON it should be using. This will actually be followed up really soon by something called structured output, which is a new feature where you can actually just give it the data class that it needs to output, and it will do it automatically. But in both cases, it actually gives you an amazing JSON. So that's a very, very short introduction. Apps have already started using the prompt API quite a bit with the existing versions of Nano. And they're using it for things like classification, summarization, content inspiration, etc. Now, with that, we're talking about things that are happening inside your app. But what if we want to expand beyond the boundaries of your app into the operating system? So that's what Ben will tell you, integrating with the intelligence system using AppFunctions.
Thank you. Thank you, Jolanda. Thank you very much, Jolanda, and hello, Berlin. It's good to be here on stage and to talk to you about the intelligence system and how you can contribute and participate in that system. AppFunctions is the main API that I want to talk about today. So let me just show you what the intelligence system is and then dive into AppFunctions. So we're creating a platform that is useful and helpful for users, and now we're adding AI-powered experiences to that allow us to anticipate users' needs. This means that you have new discovery surfaces for your app and also deeper app engagement with your users. And the users also get better and safer experiences along the way. We're doing this at every single level of the stack. And this essentially, in a nutshell, is what we mean by moving Android from an operating system to an intelligence system. Your apps are right at the center of this. First, we use AI to enhance how users interact with your apps through proactive help. And this leverages the deep understanding of Kotlin and Compose. You might have seen that already with autofill. The next generation autofill that we have uses data that you already have provided to your agents to enhance the autofill information with AI. So instead of just having the name that is being added there, you can add more information directly from something that you have stored in memory. We also help protect users. In this case, on a Pixel device, somebody got a message, and it already looks a bit scammy, but sometimes it's hard to understand, is this a scam or is this actually legit? And the AI features tell your users, hey, there might be a problem. This is a thing that you don't have to do anything about, but this is what the intelligence system already does for you. So as a user, you can understand, oh, this might be a problem, and you have that warning, and you have to move ahead very intentional across those dialogues. And we also have very helpful things that are in app context as well. So Magic Queue is the feature that we're seeing here. And it helps your users to stay in the task that they are while also using the intelligence that already is available. So there's a conversation with like, oh yeah, we're just doing some things here. And then do you want to grab lunch sometime? And then we talk about the sandwich spot that Florina recommended somewhere. And instead of me having to look that up or ask Florina again, it was like, where was the sandwich spot? The agent understands the request and provides this affordance on here. And then I can just enter this information directly by tapping onto it. That allows me to have a more immersive user experience and make it a lot easier to stay in the focus and in the zone of the actual thing that I want to do, rather than doing all the things outside of that. We're expanding this over the coming year, expanding it to multiple apps as well. And we're making your apps more proactive. So this is just the beginning. Android has always been designed to let multiple apps work together very seamlessly to complete a task for your users. It's like composing emails or pulling a photo from a gallery. First is what's done through intents, content providers, and URI, so you were able to do these things programmatically. The schema sometimes was a bit of an issue here, because if you don't have a schema, you don't have a very strong contract with your other apps, those things might break. So now, with agents like Gemini, we're taking that one step further already. So Gemini acts as an intelligent orchestrator that unlocks the user journeys across multiple apps. And we're officially entering an era where agents are becoming a new type of user of your apps. So Gemini can already understand and analyze screens. It can navigate through complex tasks and fulfill requests on behalf of your users. A user could say something like, hey, find a photo of Spot that I took yesterday and send it to my mom. That's a thing I can do myself, but Gemini can already do that on your device, and it identifies and orchestrates that task. So it looks for the photo in the Photos app, then it drafts the email, attaches an image, and then sends that message. This is multi-step reasoning with cross-app task fulfillment. In many cases, you don't have to add any code for this, but we give you the opportunity and the option to opt into task automation in different ways. So before you do that, when Gemini analyzes the screen and navigates through that task, sometimes there's things that are deemed a bit dangerous. So I want to make sure that this message really gets sent to mom and not somebody else. So you might, the agent might just stop and pause and say, hey, I've drafted everything. I can just send you over to the email app now, review it, and send it. This is also very useful for placing orders or for doing other things that you want to make sure that they are really, really correct before that's being sent. So you can either ask the agent yourself, say, hey, just don't get me up to the point, or the agent already will intelligently do that. But to truly unlock the power of the intelligence system, we give you an API that allows you to do these things and a lot more. So let's take a look how AppFunctions, as the API, powers the Android's MCP solution. Let me give you an overview of how it works. Generally, in MCP, you've got multiple actors. You've got clients and you've got servers. And you've got tools that are being passed. There's more, but right now, this is what we're focusing on. The Android platform serves as the registry for the app functions, which are the tools. And I know that Android developers don't think of their apps as servers in general, but in the Android MCP model, your Android app becomes a server. It serves the tool to the client. And by registering your app function, that is exactly how it works. So you define and declare your app function, and it's getting registered with the Android platform as part of the registry, and the tool is now available to the agents that have access to this. And the agents then act as your clients or your users. Agents can also register to the system, and to this end, they need to be granted a system privileged permission. So it's not that everybody can just act on your behalf, but those are very dedicated and specific agents that can do this. Otherwise, this would be completely locked. So any agent that does not hold this permission cannot act on your behalf or on your user's behalf within the app functions that you provide. That is the security part that we need to make sure that that you have the safety, that the users actually have the trust on the other end as well, the same that you have to trust, that you give the users the trust of doing the right thing within your app. And then agents that are privileged with that have the possibility to look up the metadata of the app functions and then call the tools. So then they can just call the tool, right? So they call the app function, say edit node in that case, and they can do the things on that and fulfill the tasks that the user has requested to fulfill. Android MCP was designed to reduce the user's workload by passing it to the intelligent system agents. It's powered with the AppFunctions API, and you get a chance to provide the core features of your app that you want to have your users available throughout the intelligent system with the AppFunctions API. You can provide the data that you want, and you can make sure that, on the other hand, you can keep things private that you want to keep private. So you don't have to share everything. Not everything is being read through through the UI itself, but the agent can query for information, and you can decide how to pass that information back and forth. So let's take a look at a quick demo of the cross-app workflow that we can do with AppFunctions. I'm in Android Studio here, and I have a couple of apps open on this emulator that I can use to show you what's going on with AppFunctions. So I have an agent app. Let me pop that out and see what's going on here. With the agent app, I can do a lot of things in here. I can take a look at registered app functions that are in here, and I can also have the agent do things on my behalf. Usually, if I were to do something, so Jolanda, maybe she hasn't read the article on the Android 17 release yet. We've got that available in the Now in Android app. Usually, what I would do is like, OK, I have to go back here. I have to search for the article, and I have to look at it. I have to share it like that, and I have to kind of do the things. You know how all this works, so I'm not going to take you all. You don't have to watch me kind of use my phone in a very cringy way. But what we can do instead is we can use Now in Android app functions. In the agent, I have a couple of app functions that are registered throughout the app. The first one is search. So is this the same interface or the same functionality underneath that I have just been using in the app? So I say, I want to look something for Android 17, and there are a couple of results, because there's an ID with 17, there's a news resource with Android 17. That's cool. I've got the URL here. I can copy it from the agent directly and close the app function. So this was an app function call. This is what it looks like to an agent. This is what you can do. This is the data that you get back, exactly what is happening. And I want to send this message to Jolanda. So I can do this here. I can, because there's a couple of app functions, I could do a call. We're not doing that. I can send a message. I don't know who to send it to. So I could just say, Jolanda, the endpoint value is a user ID, email, or something like that. And I can just add a message body. So I can search the contact here, make sure that I find, so let's see, do I have Jolanda in here somewhere? And there we go. Yes, I do have her with that endpoint value of 0. So I can just send the message like this. Again, same thing. It's a user. It's just a different interface. But cool stuff is really like this. So I said I want to find an article and send it to Jolanda. I want to send the article on the Android 17 release to Jolanda. It is connecting to the chat app. It already has looked up the information, and now it's connecting to the chat app sample. As you can see, I have sent this message a couple of times. This is the latest one. This is the article on the Android 17 release, sent entirely by that agent. So it can act on my behalf. To be very clear, I don't want you to do kind of the manual pieces or the debugging yourself. You can do this with the agent, and you can understand how your descriptions and all that works with the agent itself, which is really neat. You can see how this all works without actually me having to do all the steps by hand. But I could do this while I was driving, for example. I could just say, hey, make sure to just send an article. I remember I saw this article in Now in Android. Send it to my friend Jolanda, and it will do all the steps. So I don't, even if I forget, I've already done the thing in the time. So you have the full transparency of every call into your app with this. You have the possibility to act or not act, depending on your user, what you want them to do. And anytime the agent calls into the app, you get to decide exactly how and what to respond with. So it's basically the same as the user interface that you provide to your existing human users. It's just a bit different. And as developers, you have the full control of all the data that you're offering. You can decide what to pass, what not to pass, and what you deem private and what you don't want to share with an agent. And it allows you to seamlessly continue. As we just saw, I opened the app. I sent a couple of test messages before, but this is the message, the last one I sent. It's like, cool, OK, I can just continue the chatting in there, and everything is stored in my own app or in its backend as it is needed. So let's dive a bit deeper and see how this actually powers Android MCP. So it simplifies this integration a lot, because doing those things by hand and registering everything by hand is a lot of work. And with the Jetpack API, we provide you with the possibility to focus on the things that you want to do, and that is build apps that delight your users. So with that integration currently into Gemini, it is currently in private preview with trusted testers. And you can prepare already using a couple of tools and APIs. So let's make this actionable. After considering which parts of your app you want to provide to your users, you just annotate your functions with AppFunction. This is oversimplified. There's a bit more to it. Now, after an AppFunction has been compiled and has been marked, the compiler then generates a schema that registers the AppFunction with the system that contains the ID of the AppFunction, description, parameters, and everything, so the agent actually can act upon those things. I struggle writing my Android manifest by hand. This would be weeks of me being frustrated. So we have a compiler that takes care of you for this. So every time your app gets recompiled, this file is the output that actually gets registered with the Android system, so your app and the agent can talk to each other using AppFunctions. For now, with an AppFunction, like I said, it's a bit of an oversimplification. You actually have to add the annotation to usually a suspend function, because you want to make sure that this can do stuff in the background and it doesn't block anything and you don't get any nasty ANRs while you're doing things in the background. So you have the AppFunction annotation. That is already available in the Jetpack, in the AppFunctions Jetpack API of the Alpha 9 APIs, and you can use that today. And you can define data models similar to the ones that you basically, it gives you structured ways to store things in a data class. So very similar to what Jolanda just mentioned. Instead of just passing back and forth a JSON, you have the possibility in your app to have an AppFunction serializable that can make your data complex rather than just passing over primitives. And to reduce the guesswork for an agent and actually tell the agent what your AppFunction can do, you provide a description. And that is what this neat parameter here is, the isDescribed by KDoc. So in the Kotlin documentation, usually you write that for your fellow developers, and you say, this thing does something. And basically, that's the same thing, but this is your this helps your agent to understand exactly what a specific app function does. So this is for the send app function. So it sends a text message with optional image attachments. And then there's all these parameters that get passed in. I could also do things like telling the agent you have to call another app function before to make sure that everything works the way it should work. And because we've been asked this a lot, I want to make sure that you understand that we also have the possibility to turn off app functions if you don't want to provide them to a specific user. So if your user is not logged in, you have the possibility to use the app function manager and just disable the app function. When they are logged in, you can enable it. Same for somebody that has subscribed. If the user is subscribed to your app's service, then, or if they're a premium user for whatever reason, you can just enable them. So you can toggle app functions at compile time to be enabled or disabled and decide when you want to turn them on or off during the during the runtime. We have a couple of changes with the new Alpha 10 that is incoming. It's not on our Maven repository just yet, but it should be there very soon. App functions run in a service, and we used to hide that before, and now we don't anymore. And the reason for this is this kind of awkward wrapper of context. We decided that we wanted to add a couple of things maybe to this, but we then said, no, it's actually not the best thing to do. And it's this quirk that you have to pass this parameter. It makes the API a little less natural and doesn't feel as good. So now we're exposing that service. This service, where you annotate it with the AppFunctions service entry point, allows you to have access to your app's lifecycle and state directly as your app function gets executed. And as a fun side effect of that, it removes the need to have the app function context parameter. That's one of the reasons why we're saying this API is still experimental. It is still in alpha, and it is evolving. So you already can use it for local prototyping. Works really well. Like you saw, even with a demo, things go sideways sometimes, and you try to understand what's going on, and it helps you to see how things are going to help you with your development testing. The API might undergo some more refinements before we consider it stable. And right now, we limit production access to agents. And we do that very deliberately to make sure that we're doing those things in a way that is as good for your users as it can be. You also have something available for you, which is the skill. Simona will talk about skills later, so I won't go into too much depth. This skill plugs into your favorite IDE, like Android Studio, and it allows you to act as a coding assistant where it knows everything about the AppFunctions SDK, all the things that you can and want to do. And like I said, you want to test those app functions. And testing, there's basically a lot of types for testing. One of them is deterministic testing, so there's no changes. So this is instrumentation, unit tests. If you test the code of your app function and how it works, that's the same thing. It gets interesting with the probabilistic side of things, and that is where the LLMs come in. And this means you can end-to-end test with things like the agent that I just showed you. The last step of the skill that we have available is a ADB integration, because app functions can be called via ADB. You don't want to pass forward these things yourself. You can just tell the agent, now I want to connect to the app functions that are available and do the thing. So everything that I just did on the in the agent, we can do that directly with the development agent. So you don't even have to leave your IDE. So you can have the conversation from build the skill, build the app function, and test the app function all in one conversation with an agent. So as part of that step, it just says, like, OK, it has to follow the description. There's a kind of a system prompt for this, and make sure that the JSON escaping is done the right way because of shells and all that. And you can tweak the descriptions in that directly until you're happy. So you can have a conversation with the agent, as you usually have, until everything's fine. And to make the testing more seamless kind of from a user's perspective, rather than from a developer's perspective, we open sourced the agent as well. So that agent is on the GitHub repository, on the AppFunctions, GitHub Android AppFunctions, and you can download it, provide your own API key, and work with it. So you can even verify your configuration. So if you find an app, I know this is very small, you can say, can see what's going on there. It's not supported because there's some issues. It couldn't find a service. It couldn't find the manifest entries and all that. And it says some things that you can do to fix this. This is just for debugging if your app doesn't do the right thing here. You can, like I showed you, list and verify the app functions to execute directly. And with your own API key, you can experience this whole experience in first person. What I want you to take away is you can experiment with app functions today and use the AppFunctions Jetpack library today to play around with it. You can use the testing agent. You can use the skill right now. If you think your use cases should be part of the early access program, register, sign up, let me know what's going on, and sign up for the early access program. Thank you so much for your time here today, and enjoy the rest of the show.